So, hello everyone. Today we're going to see another question that goes by merge k sorted linked lists. Let's just see the question. K sorted linked list, right? So we'd be given k linked list and that would be sorted individually. Every linked list is sorted in itself. Let's say we have three linked lists. Linked list 1 is sorted, linked list 2 is sorted, linked list 3 is sorted. But if you combine all of them, combine in a way that you append linked list 1 and then linked list 2 and then linked list 3, they are not going to be sorted. Do you get that? That is to say 1, 3, 7, 2, 4, 8. So, but if you join 7 and 2, they are not sorted, right? That is what I meant. So you'd be given an array with all the heads together. Your task is to merge and your task is to merge all these lists and return the head of the merged list, whereas you'll be given an array of n sorted linked lists. This is the head of the array of all your linked lists. Got it? So the first thing that I can do, the naivest thing that comes into my mind is that if to return a sorted linked list, complete sorted linked list, just sort it off, right? So what I do is, if I talk about my approach 1, let's just go with approach 1. Okay. If I go with approach 1, that was a little light on the screen, right? Approach 1, let's say what is our input? 1, 3, 7, 2, 4, 8, and 9. We have 1, 3, 7, 2, 4, and 8, and then 9. And we have to merge all of these, right? So approach 1 is take up an array, go through all of them, and just keep appending in your array. Make sense? And then what do? Just sort this array. And then create a linked list and return it. If I talk about the time complexity, at first, let's say each of the linked list has m elements. M is, the most elements in all the linked lists. Like, let's say, had this been 10. So m had been 4. I take the max size of all the linked lists given to us. That is in simple terms, right? So first of all, you traverse through all of it. N is the number of linked list. M is number of nodes in a linked list. Okay. So first of all, you traverse through the entire given all the linked list to find all the elements, and then you put all of them into an array. So you give me the space complexity as, makes sense? Because this is the size of the array that you created. And then you sorted it off. And what is sorting time complexity? N cross M log N cross M. And then again, you traversed through this sorted array to create a linked list. Again, O of N cross M. Isn't it a very expensive operation? As you cannot see on the screen, it's just got so much time complexity, right? So now we need to work on the time complexity part. And also on the space complexity, because the best approach to any question is your constant space complexity, until unless they have asked you that, hey, like they give you a linked list and they asked you to create an array. Now that is where you have to employ a data structure. You cannot return without employing a data structure, right? In those cases, no. But in other cases, I prefer the space complexity that is most constant. Or else, there's always sometimes a trade-off between space complexity and time complexity, and you have to decide, given on the base, given on the actual use case, what data structure suits you best, what approach suits you best in those cases. But given in this case, we're going to have something that is going to get this in a favorable condition. So with this, we're going to see the approach 2. So you remember we've done merge 2 sorted linked list. And if you remember, we did merge 2 sorted linked list, you would remember the time complexity that we used was n1 plus n2. And the space complexity was, and we used the approach merge sort. Are you able to remember something? If not, you can just go back to the video of this merge sort and then just see it. Not merge sort, sorry, merge to sorted linked list video. You can go back and just check it through. Now, what the thing is that, when we do this, all this thing, it is good and it is best. But what is the thing that we're not making use of the fundamental that we have been given sorted linked lists, individually sorted linked list. Had I told you to merge n list, this would have been the best approach. Makes sense, right? But now what the question is that you already have merged linked lists. Sorry, you already have sorted linked list. Individual linked lists are already sorted and you're not making use of that fact that is being given to you. So now we're going to make use of that fact. What we're going to do is 137248. So now what we're going to do is we're going to imply merge to sorted on this, right? Does it make sense? And then we will get one entire linked list, and then we're going to use one entire and one entire. So are you getting it? It's kind of I merge and sort two linked lists, then I get one linked list, then I make use of the resultant linked list out of here and merge it with the third linked list. I get the resultant linked list, I merge it with the fourth linked list. So it's like n times what it is, you use n times your merge two linked list code. Does it make sense to everyone? If it doesn't, please let me know in the comment section. I can make videos again on the same topic so that you could, understand it well. Now let's just get to the code part because that is the approach. Because if you return the head, we have to keep the return type as node. Merge k lists. And you have your vector given to you as array. Make sense? And yeah. You can pass it by reference or anything because you're not going to make use of it. You're not going to make changes to it. And then let's say this is my array size. My head, I'm going to keep a head out here. And that is going to be your array 0. And then I'm going to run a loop. Not from 0, but from 1. And this way I'm going to merge two linked lists and then again keep it to head. So head is equal to sorted merge. I'm going to keep this name only. Now you'll understand why, because I'm going to use my previous code. Make sense? And then finally, I'm going to return my head. And then if you give me a second. Sorry. I think, no, I just don't want this. Just give me a quick second. And this is just, let me just copy paste out here the code that we've already used before. Give a second. Because we've already done sorted merge code, remember? Yes. So we're going to use that same code here. I will explain it to you again. Node star sorted merge, that is why this function is going to call up here with head and your next array I. Array I is starting from int I is 1. And then if head is null, this, and then you're going to just keep on dragging it out to head 1's data, head 2's data, else and so forth, so ahead and so forth. So what do you get as time complexity in this case? Let's talk about our important constraints of time complexity, space complexity. It is an in-place sorting space complexity constant until and unless you're considering big O of n, which is your recursive stack space. Right? And time complexity First of all, you remember for that, we used to have n1 plus n2, where n1 was the number of nodes in linked list 1 and n2 was the number of nodes in linked list 2. Now, if I take m to be the greater size of the linked list, so I will have 2m, that is m plus m, 2m. First, for the, the part where we are actually merging it off. Second step is what? You're doing it. Sorry, it's not the second step. We had it once. If you do it once, it's big O of 2m. But now you're doing it n times. So this becomes 2mn twice nm, howsoever you write it. You should be able to make it, you should be able to just express it off clearly, positively to your interviewer, and that's it what matters. So you're able to get how I'm getting 2m, how I'm getting n, how I'm getting 2nm right there. With this, I think you're good with it, because this function is what we've taken from the previous question as well, from the previous question. And if you're not able to understand how this came, just please go back to the merge two sorted linked list video. And if you're still not able to get in, please write in the comment section, use Gforms for the purpose. And I'm most ready to just make out more videos or more reclarifying videos on it. Just let me know. Your thing is just to let me know of whatever you want in this. Whatever reclarifications, whatever explanations you want, just you need to let me know about them. With this, I think we're good. And if you have any doubts, if you have any concerns, you know where to go. And yes, if you liked in the video, just go in, subscribe to the channel, because the playlist is still in the process. With this, yes, bye-bye.